All right, let's review absolute value functions. First, we're going to evaluate functions, which means all we're going to do is plug in some numbers into our equation. So in this first one, f of x, I'm going to plug in the number -4 in for x first. So I'm going to do f of -4. Remember, all this means is that I'm plugging in -4 for x. That's all that means. When I actually do it, it's over here on the right-hand side. So if I work inside the absolute value bars first, I have -4 plus 3, that is -1. And then I take the absolute value of -1. Remember, absolute value means the distance away from 0. So -1 is the distance of 1 away from 0. Basically, we just say the absolute value always has to be a positive number. So f of -4 is +1. Now let's plug in +7. So I'm going to do f of 7, which means I'm plugging 7 in for x. I'm going to add those two things together. So absolute value of 10. The absolute value of 10 is just +10. So f of 7 is equal to 10. All right, now let's do the g function. So if I'm going to do g of -4, that means I'm going to do absolute value of -4. Then I'm going to subtract 5. So now my order of operations tells me take the absolute value first. So the absolute value of -4 is +4. And then I'm going to subtract 5. So 4 minus 5 is going to give me -1. So g of -4 is equal to -1. And now I'm going to do g of 7. So I'm plugging in 7 into the g function. So first I'm going to do the absolute value of 7, which is +7, and I'm going to subtract 5. So 7 minus 5 is 2. So g of 7 is equal to +2. Now let's talk about the graphs of absolute value functions. Remember that the general equation is y equals a times the absolute value of x minus h, and then we have plus k afterwards. Remember that the vertex of our absolute value is at h comma k. And remember that h is the opposite of the number in parentheses. So always remember that. And also remember that the graph is a V shape. We talked about that a lot of times in Algebra 1. And remember, we also said that if a, that's this part right here, the number in front of the absolute value, if a is positive, then the graph opens up. And if a is negative, the graph opens down. So an upward V would be like a normal V. A downward V would look like that, upside down. Okay. Also, A tells us whether the V is going to be wider or narrower. So the graph is wider as long as the absolute value of A is less than 1. So really that just means if it's anywhere between -1 and +1, any of those numbers between -1 and +1, think fractions, think small decimals, then our V is going to get wider. It's going to get narrower if the absolute value of A is greater than 1. So these are numbers like 2 or 4 or 5. That's just because that's our slope. So A is the slope to the right of the vertex, and -A is the slope to the left of the vertex. So because A tells us the slope of those V parts of the shape, if that's bigger, then we're going to have a narrow, steeper V. And if it's smaller than 1, then we're going to have a wider V. So let's look at some examples. In this first example, what is the vertex? Well, the vertex is HK. So remember, I take the opposite of this. So the opposite of +6 would be -6. And then this is going to be my K value, the -10. So my HK is -6, -10. Does the graph open up or down? Remember, that's when I'm looking at the number in front of the absolute value. That's my A. So since A is positive, it's going to open upward. And is the graph wider or narrower than y equals absolute value of x? So I'm going to look at A. A is 2. And since 2 is greater than 1, that means it's going to be narrower. It's going to be steeper, the steeper lines that create that V. All right, let's look at another example. If we graph this absolute value function, we first want to know where is the vertex. So that's the opposite of the number inside of the absolute value, so that's -4, and then the k value, which is +1. So I would graph -4, 1. So -1, 2, 3, 4, 1. There's my vertex. The slope is going to come from the number in front of the absolute value, so even though it's not written, we understand that to be 1. So I'm going to count up 1 over 1, up 1 over 1, and that gives me the slope on the right-hand side of the V. And then since I know it's a V, I know it has to go in the opposite direction. So that's what we meant by -A. So -1 is going to be the left side. So if I go left 1, up 1, then I'm going to get the other side of the V. So I don't want you to get too bogged down by A and -A and all that stuff. All you need to know is that the slope gives you how steep the line is, and make sure you make it symmetrical. Okay, so if I were to list one point, this first point that I plotted, that would be the point -3, 2. And then when I went to the other side, that symmetrical point, that would be the point -5, 2. Again, I don't want you to get bogged down by that, okay? Don't stress out about that, but that's just so you can see where those points are coming from and why the graph looks the way it does. Okay? Let's do another one. So if I want to graph this equation, y equals -2x minus 3 plus 1, I again start with the vertex. I'm going to do the opposite of the number in there in the absolute value, so that's +3, and then the k stays exactly the same, so that's +1. And my slope comes from the number in front of the absolute value, so that's a slope of -2, which means that it's opening downward. So if I plot 3, 1, 1, 2, 3, 1, and then if I do my slope of -2, so this is -2 over 1. So I'm going to go down 2 from the red dot and over 1. Down 2 over 1. And that makes the right-hand side of the V. Then I'm going to do the same thing for the left. So I'm going to go down 2 into the left 1. Down 2 into the left 1. That gives me the left-hand side of the V. What I don't want you to do is to keep going past the vertex like that. That would make an X, and that's not what we want. Okay, we don't want that. So always make sure that your slope only goes in one direction. It makes a V, not an X or anything else. Okay, it has to be a V shape. And then if you wanted to, we could identify some points. So this first point that I graphed, that was the point 4, -1. And then the symmetrical point on the left-hand side, that was the point 2, -1. Okay. And then one more. Now I'm going to give you a graph, and we need to write the equation. So again, we're going to start by finding the vertex. So the vertex of the V, where it switches, the bottom of the V is right there. So that point is 0, -3. All right, and we're going to plug that into the general equation. Remember, this is H and this is K. So my equation is y equals, we'll figure out A in a little bit, and then we're going to have x minus 0 in absolute value, and then -3 is my K. Now keep in mind that x minus 0, that's just x. So I'm just going to have x in the absolute value when we make our final equation. So the next thing we need is this a value. I need to figure out what do I put in front of the absolute value. And we get that by finding slope. So all we're going to do is start from the vertex and then count up to the next point. So if I count up to and over 1, that gives me a slope of 2 over 1. So I know my a is 2 over 1. And I want to make sure that it's a positive 2 because this v is opening upward. So when I write my final equation, I'm going to plug in 2 for my a. I'm going to have the absolute value of x. Remember, I'm not going to write the minus 0 because I don't need to. And then I'm going to have minus 3. So that's how we can write the equation of an absolute value function.